Hello and welcome to this second video tutorial. In the first video, we looked at solving literal equations to isolate a given variable. In part two, we're going to look at unit conversions. First, we'll look at metric unit conversions, converting between, let's say, a metric base unit and a metric prefix, or from one metric unit to another. Then we'll look at how do we convert between completely different units. In order to convert, you must have some conversion factor. Now, one of the things that can be done in many cases for a metric conversion is to have a really good understanding of where the metric prefixes fall and what their numerical equivalents will be. That's especially true for the really small metric prefixes like nano and micro, okay? So we'll get to those when we get to those. First, before we begin any metric conversions, let's take a look at number 10. When you are converting units, you start with one value and you have a series of metric conversions along the way. So how many seconds in a year? So essentially what we're going to do is we're going to kind of formulate a path of unit conversion, okay? And then we'll attach the numbers to them. So we're going to go from years. And from years, we can go to days. I'm going to abbreviate days with a D. And from days, we can go to hours because there's 24 hours in a day. And then from hours, we can go to seconds. Now, you can go from minutes because there's 60 minutes in an hour and then 60 seconds in a minute. Or you can go 60 times 60, which is 3,600 seconds in an hour. So this is the pathway we're going to look at when we take a look at how many seconds there are in a year. So starting with 1 year, then what we're going to do is we're going to multiply times a conversion factor that has a year down here. So it can cancel with that up there. So if we're going to go from years to days, then we're going to multiply and go ahead and cancel as you go. Then we're going to multiply by another conversion factor that goes from days to hours. Okay, cancel as you go. Then we're going to multiply by the last conversion, which goes from hours to seconds. And you can see we arrived at the unit we want, which is seconds. Okay, now you fill in the numbers. So there are 365 days in 1 year. Now, if you count the whole leap year concept, then it's 365.25 or 365 and a quarter days every single year. And then those 4 quarters add up to 1 full day, which is February 29th every 4 years. Okay, but we'll just keep it simple, 365 days in 1 year. Same thing with hours. They're actually 23 hours and 56 minutes in every day, roughly around there. But we'll just round it up to 24 hours that we know about for 1 day. Same thing, 60 minutes times 60 seconds is 3,600 seconds in 1 hour. Go ahead and multiply all that across, pause the video, and see what you get. Okay, if you did this right, you should have gotten 31,536,000 seconds in 1 year. Okay, now to do some metric conversions along the way, there's a couple ways we can do this. We can use a method called the metric staircase, which I'll share with you in a minute, or we could use the numerical equivalent of metric prefixes, okay? And I'll write some of those up above. So for instance, if you see the prefix nano, nano means times 10 to the negative 9. It means 1/billionth of something. If you see this Greek letter mu, this stands for micro, and that's 1/millionth of something, or times 10 to the negative 6, okay? If you see milli, that's times 10 to the negative 3, right? Kilo is times 10 to the positive 3. Centi, okay, is times 10 to the negative 2. Okay, so just throwing out there a few of the most common ones that you're going to encounter. Okay, so first let me show you the metric staircase. It's a really easy visual way of kind of getting through this. Okay, so what I'm going to do is I'm going to write down 7 stairs. Now, right in the middle staircase are your base units like meter, liter, gram, second, right? Those are the 4 most common ones. There are other ones too, like amps, okay, and other units that are base units along the way. Well, as you go up the stairs, you're increasing by 1 factor of 10. Okay, every staircase is a factor or a multiple of 10. So this would be deca, so a decameter, decaliter, decagram, decasecond. H stands for hecto, hectometer, hectoliter, hectogram, hectosecond. And then K stands for kilo, kilometer, right? You would say it as kilometer, kiloliter, kilogram, kilosecond. If you go down the stairs, you start getting into factors of 10 that are smaller than 1 base unit. So 1/10 of something is deci, which is symbolized by a D. Decimeter, deciliter, decigram, decasecond. 2 factors of 10 lower than a base unit is C for centi, and that's centimeter, centiliter, centigram, centisecond. And 3 stairs down is 3 base units smaller, 3 factors smaller than the base unit, and that would be milli, millimeter, milliliter, milligram, millisecond. The way it works is this. When you go up the stairs, you're going to move the decimal that many factors of 10 to the left. When you go down the stairs, you're going to move that decimal how many factors of 10 you go to the right. So down the stairs, we move the decimal to the right. Up the stairs, we're going to move the decimal to the left. Let's try this. In number 11, we're going 28 kilometers to centimeters. Okay, so I'm starting off with the number 28. Now, I don't see a decimal there, so I have to know that if I don't see a decimal, it's assumed to be at the end of the number. Okay, now I'm going from kilo to centi. How do I do that? I'm going to go down 1, 2, 3, 4, 5 stairs. So if I do that, I'm going to move the decimal 1, 2, 3, 4, 5 times to the right. You can see there's 5 0 placeholders, which would give you 28 and 5 zeros, or 2,800,000. Okay, number 12, you're going from kilo to milli. So you're going from all the way up the stairs at the top to all the way at the bottom. So I am going 1, 2, 3, 4, 5, 6 stairs down. That means I'm going to move the decimal 6 places to the right. So we have 45. I'm going to go 1, 2, 3, 4, 5, 6. That would be 45 with 6 zeros. Or 45 million milligrams. Okay, now in 13, you're converting multiple units at once. You're converting centimeters to meters and then minutes to seconds. So start with the original value, 85 centimeters per minute. Now you have to change 1 unit at a time. So first I'm going to change centimeters to meters. So I'm going to write centimeters down here and meters up there. You can see centimeters cancels. Then I'm going to change minutes to seconds. Well, if minutes is down here, I need to copy that up here so that it can cancel. I'm going minutes to seconds. Now fill in the numbers. There are 100 centimeters in 1 meter, and there are 60 seconds in 1 minute. So if you multiply those two, you can see you get 6,000, and we're taking 85 times 1 divided by 6,000. Okay, put that in your calculator and we get 0.040142 meters per second. Okay, now we have 3.3 times 10 to the 8 meters in 1 second. Okay, and we need to get this into kilometers per day. So first thing I'm going to do is turn meters into kilometers. So meters has to go down here, kilometers goes up here, meters cancels. Now we're in kilometers per second. So now I'm going to multiply by another conversion factor that puts seconds up here, so it'll cancel with seconds down here. And I got to go from seconds to hours, okay? And then I can have a final conversion factor that would go from hours to days. Okay, fill in your numbers. There are 1,000 meters in 1 kilometer. There are 3,600 seconds in 1 hour. There are 24 hours in 1 day. So what you'll do is you'll multiply this times this times this, and then we'll divide by 1,000. Okay, pause the video and go ahead and try that yourself. Well, if you do this right, you get a very large number, 25 trillion 920 billion, no, sorry, 25 billion 920 million kilometers per day. Which, by the way, this is the value for the speed of light. Tells you how fast it's going and how far it would have to go in just 1 day. Number 15, we are going nanometers to meters. Now you'll notice nanometers is not on here, so we're going to probably have to use our metric prefix there, and that's pretty easy. All we're going to do is replace this with times 10 to the negative 9. So 823 nanometers is the same as 823 times 10 to the negative 9 meters. You can see I just replaced nano with times 10 to the negative 9. Now that's not proper scientific notation. So the way we do that is if I need to put that in proper scientific notation, the prefix needs to be between 1 and 10. So I'm going to take the decimal here and I'm going to move it twice this way. Well, anytime you move the decimal to the left, okay, your number gets smaller. Anytime you move it to the right, factors of 10, your number gets bigger. So if this is getting smaller, then this has to get bigger. Now, a negative number gets bigger if it gets closer to 0, right? So that number has to get bigger by the same number. So I'm moving this 2 factors of 10 smaller. That means I need to make this 2 factors of 10 larger. Well, what is 2 factors of 10 larger than negative 9? That'd be negative 7. So I would get 8.23 times 10 to the negative 7 meters. Okay. Now, number 16 is interesting because we can take the stairs and go from meters to millimeters, right? But then you have to just kind of convert and rewrite the exponent proper scientific notation. So meters is there, millimeters is down here. So you would go 1, 2, 3 to the right, which means I would move the decimal 1, 2, 3 to the right. And I get 8,800 times 10 to the negative 8 millimeters. It's not proper scientific notation, so to fix it, I would put the decimal back 3. Now remember, I made that number 3 factors of 10 smaller. That means I need to make this 3 factors of 10 larger. Remember, larger means closer to 0, okay? A larger negative number is closer to 0. A smaller negative number is is smaller than 0. So this means that turns that into -5. So this would really be 8.8 times 10 to the -5 millimeters. Okay, number 17, we're converting that from meters into micrometers, which is times 10 to the -6, a millionth of a meter. And so we're going to start off with our number, 1 times 10 to the 11 meters. We're going to multiply times a conversion factor to go from meters to micrometers. Well, there are, in 1 micrometer, there are 1 times 10. You actually do this one of 2 ways. You could go 1 times 10 to the -6, or 1 millionth of a meter in 1 micrometer. Or you could go 1,000,000 micrometers in 1 meter. Either way, it gets you the same answer, okay? And you would end up with about 1.5 times 10 to the 17 micrometers. Pretty small. All right, now converting area, it can be a little tricky sometimes. So go from square meters to square centimeters. We're gonna go 7.6 meters squared. We would say that's square meters. Okay, and you're multiplying that by, and here's how you do it. We have to have meters squared here to centimeters squared here. So square meters, square centimeters. The way you do that is put the unit there first, meters to centimeters, and then you square the unit and the number. For instance, there are 100 centimeters in 1 meter. But see, when you square that, here's what you actually get. So we have 7.6 square meters times, what you're really doing, ladies and gentlemen, is you're multiplying by the square of 100, which is 10,000 square centimeters in 1 square meter. That cancels, and you're really multiplying 7.6 times 10,000, which is 76,000 square centimeters. I hope you found this tutorial to be helpful. Thank you, that is all.